Yeah, okay, guys. So yeah, let's get started without any further ado. In today's class, we shall be continuing from where we left off in the last session. I think we discussed up to the classes, class A, B, and C. So today we're going to talk about some other concepts. So the subnet mask and how do you assign an IP address and some important protocols as well, DNS and DHCP protocol. Okay. But before that, if you remember, we have only covered class A, B, and C. We didn't talk about class D and class E, right? So now, as mentioned, class D and class E are also public IPs itself. But these are special public IPs. Now, they're not used for your general ISP internet connections. They're used by special organizations. Example, your military organizations, your government portals, your weather forecasting services, news broadcasting services. So all of these organizations go for Class D and Class E public IPs. These IPs are never assigned to, again, the general public for internet access. They're not used for internet access or they're not given to the ISPs, internet service providers. They're only reserved for these organizations. Most of the times, government organizations and military organizations and research and development organizations as well. Yep. So those separate bodies use Class D and Class E. Okay. Moving on, let's talk about subnet mask today. So if I go to my command prompt, and in my command prompt, if I type ipconfig, you can notice this shows me my private IP here, 192.168.0.5. And below that, there's something called subnet mask. Now, what is the subnet mask? Okay. So this is a value for the computer to understand or the information system to understand which class it belongs to. For us humans, we can easily identify it with alphabets N and H. But how does the computer know what the alphabet N represents and what the alphabet H represents? Okay. Or how does it know which class contains how many network portions and host portions? Okay. So what the computer does or what any other information system does is it assigns the network portion with the value of 1 and the host portion bits with the value of 0. So in class A, where you have one network portion and three host portions, there's all ones in the first portion and all zeros in the last three portions. Again, as you can see, in the network portion, there's all ones, and in the host portion, they're all zeros. And now, when you convert that from binary to decimal, you get first for all ones, you get 255, and for all zeros, you get simply 0. So for class A with one network portion and three host portions, subnet mask is 255000. So when the computer sees that subnet mask, it understands that, okay, I belong to class A, and they can connect a maximum of 255 into 255 into 255 devices. Okay. Similarly, when you go to class B, which has two network portions and two host portions, subnet mask is 255 25500. Okay. And for class C with three network portions and one host portion, subnet mask is 255 255 2550. Okay. So for my computer here, when the subnet mask 255 255 2550 is assigned, it understands that, okay, this IP belongs to class C. And since it's belonging to class C, I can only connect a maximum of 255 devices, not more than that. Okay. So it understands the range, the first IP and the last IP and the entire list of IPs it can communicate with in its class. Okay. And then you have default gateway. This is just a fancy name given to your Wi-Fi router. So the router gets the first IP in the network, 0.1 IP. So that is always assigned to the Wi-Fi router. Okay. It's called the default gateway. Why is it called the default gateway? So if you look at this image here, as you can see, this is the gateway between the two different networks. Okay. So when any of these devices, okay, so let's say whether it be this device or this device or this device or any device for that matter, when they want to send the packet to the internet or when they want to receive the packet from the internet, they always have to send the packet to the gateway first. Okay. Unless and until it passes through the gateway, it can't reach the other network. Okay. Similarly, when they're getting data back from the internet, let's say from Google, that always has to pass through the router as well. So this is the default gateway between the public network and the private network. Hence the name default gateway for us. Okay. Is that clear, guys? Any questions or doubts up to this point? Anyone? Sanya, any questions? Jeevan, Sandeep, Sumit, Vaibhav, any questions? Right. Sanya, am I audible? Can you hear me? Any questions? Okay, perfect. Okay. I didn't check the chat. Right. Moving forward. So, one second. Where is this? Right. Okay. Now, where is my? Okay. Right. Apologies for that. So, as mentioned, that's about subnet mask and that's about default gateway, guys. Moving on, let's talk about how do you assign a private IP. Okay. So, as mentioned, public IPs are in the control of the ISP. So, we don't have the control over that. They assign the public IP themselves. But the private IP is in our hands. We can assign any private IP of our choice to the system. Right? And usually your private IP is assigned in two ways. Either you get it automatically from a DHCP server, or you can get it manually from the control panel by you assigning it yourself. Okay. We'll talk about the automatic method later in a while. Okay, but let's talk about how do you assign an IP manually from the control panel. Okay. There's a certain technique, there's a certain procedure for that. Okay. First, you open up the control panel. In the control panel, you go to network and internet. In network and internet, you go to network and sharing center. In that, you go to change adapter settings. Then you right click on the adapter, which you want to change the IP. And then you go to properties, IPv4 properties, and then you assign the IP address. Okay, so this is the entire pathway for assigning your own IP manually in the control panel. So if I show you this practically, you can go to your control panel here, search for control panel. In the control panel, click on network and internet, then network and sharing center, then change adapter settings. And here you right click on the adapter for which you want to change the IP. Click on properties, IPv4 properties, Internet Protocol version 4 properties, and here you assign the IP. Okay, so right now I'm getting it automatically from a DHCP server. That's what the first option denotes. If I want it manually, I can select the second option and assign the IP myself. So if I give another IP, let's say 192.168.0.100, this will be the IP that is assigned to my system. Okay, but please note, always assign the IP of your same network as the default gateway. So if you remember, my default gateway was 192.168.0.1. Okay, so the first three octets should always be 192.168.0. So that it can communicate with the Wi-Fi router. Okay, and now the subnet mask for this, since this is class C, subnet mask is automatically set to 255.255.255.0. If I give a class B IP, let's say if I give something like 172 something, 172.16.0.1, then the subnet mask changes to 255.255.0.0. It knows that this is class B. And if I give class A, can anyone let me know what a class A private IP? Yes, correct. That's 10.0.0.1. Okay, so for class A, the subnet mask is 255.0.0.0. Okay, so now I'll go back to my class CIP itself, 192.168.0.100. Okay, then the subnet mask is assigned. Then the default gateway, your router's IP again, 0.1. And you have to specify the DNS server IP as well. Now, don't worry, if you don't know what a DNS server is, we'll talk about that also in a minute. But just in case, if you don't know what to assign here, you can always go for Google's DNS server IP. If you go to your browser, and in your browser, if you just simply search for Google DNS server IP, Google DNS server IP, this will provide you two addresses. One is 8.8.8.8 and the other one is 8.8.4.4. And you can enter any one of them, 8.8.8.8 or alternatively 8.8.4.4. Now, don't worry what these IPs are. I'll talk about these in a minute. Okay. But this is how you have to assign an IP manually. So you would assign the IP, you would assign the subnet mask for it, you assign the default gateway, and you give the DNS server values. And as soon as I click OK, my system's IP will change from the existing value to the new IP address that I've specified here. Okay, but I won't be doing that now because if I change my IP, we will get disconnected from the meeting. So my connection will reroute through the new IP. So that will cause interruption in our sessions. So I won't do this right now. Okay. So I'll go back to the first option, opt in an IP automatically. Okay. So that is how right now, currently, that's how I'm getting my IP. So this IP 192.168.0.5 is being obtained automatically from a DHCP server. Okay. So that's the other method. But the main question that arises here is how am I getting it automatically? Okay. And what is a DHCP server? So to understand about a DHCP server, let me show a very simple diagram. Okay. So DHCP stands for Dynamic Host Configuration Protocol. Excuse me. So now, as mentioned, the main purpose of a DHCP server is given in the name itself. It's to dynamically or automatically configure an IP address to every device in the network. Now, if you ask me where is the DHCP server in my local home network, the Wi-Fi router itself acts as a DHCP server. So in our home network, the DHCP server or the Wi-Fi router is the same device. Okay. And it gets the first IP in the network. And the DHCP server also has a pool of free IPs. So it has a list of IPs basically. So from the next IP, 192.168.0.2, 192.168.0.3, 192.168.0.4. Okay. Like that, the pool goes on up to the last IP, 0.255, let's say. Okay. Now, whenever there's a new device in the network, these devices automatically get an IP from the DHCP server. Okay. So this might get 192.168.0.2, and this might get 192.168.0.3. Okay. And whenever the IP is assigned, that IP is removed from the pool. Okay. So now the new pool begins at 0.4. This becomes 5 and this becomes 6. Okay. And please note, you will never use the last IP, 255. This IP is commonly known as the broadcast IP. Okay. What I mean by broadcast IP is whenever a packet is sent to this device, it gets sent to every other device in the network. So if you send one packet to this system, it gets sent to every other system in the network. So that's what broadcast is. Okay. Now, oh, sorry. Control Z. How do I remove this one thing? Much better. Right. So now let's assume I get one more device in the network, a new device. Okay. So now whenever I connect a new device and when it is selected on that option, obtain an IP address automatically, your system now gets an IP with something called the DORA process. Okay. So this DORA process is nothing but a 4-step process. First step is this system starts discovering or tries to discover where the DHCP server is. So it sends a packet to every other device in the network. How does it do that? It sends a packet to the broadcast IP. So whenever a packet is sent to the broadcast IP, it is sent to every other device. Okay. So this packet is called the discover packet. It is trying to discover who the DHCP server is. So it's asking each system, are you the DHCP server? Are you the DHCP server? Are you the DHCP server? When it reaches the wrong devices, they just block that packet. They don't respond to it at all. Okay. But when it reaches the correct system, that system responds back saying, hi, I'm the DHCP server. You were looking for me and I can offer you an IP address. So now an offer is made by the DHCP server saying, hi, this is an available IP. If you want, I can offer that to you. And for that, your client says, hi, thanks for offering me that IP. I now generate a request to you specifically. So only to the DHCP server now a request is generated saying, hi, thanks for allocating that IP. I request you that you don't give it to anybody else and just assign it to my system. Okay. And for that, finally, your DHCP server sends a confirmation saying, okay, I've got your request and I send a confirmation, also commonly known as an acknowledgement. Okay. And with this acknowledgement, the system gets the IP assigned 192.168.0.4. And as soon as it is assigned here, it gets removed from the pool here. So this becomes, next IP becomes 5. Okay. So this entire process happens spontaneously as soon as you enter the Wi-Fi password and click on connect. For a very short duration, you see that message obtaining IP address. Not sure how many of you have ever observed that, but during that process, this DORA process occurs. Okay. DORA stands for discover, offer, request, and acknowledgement. D for discover, O for offer, R for request, and A for acknowledgement. Okay. And this is what happens between every device that is connected to a DHCP server. Okay. And with that DORA process, each system gets a unique IP in the network. Okay. Is that clear, everyone? Any questions, any doubts? Sanya, Jeevan, Sandeep, Sumit, Vaibhav. Perfect. Okay. So if I had to show you the DHCP server, guys, again, I can just log into my router in the browser. As mentioned, my Wi-Fi router itself acts as a DHCP server. And I can go to network, LAN settings, and you can see my TP-Link router is acting as a DHCP server. Okay, it's getting the first IP, and it has a pool of IPs. So I'm not giving the entire pool. I'm only connecting from 2 to 199. If I want, I can change that to 254 as well. Okay. And from that pool, each system is getting a new IP assigned. 0.234 are assigned to these devices right now. Okay. So that is how a DHCP server works in our home network. Wi-Fi router itself is the DHCP server. Okay. Now, moving on. What is a DNS server? So if you remember when I was assigning an IP manually, it was asking us to enter the DNS server IP. To understand about DNS servers, I can use a very simple example. The example of our contacts application in our phone. Okay. So no matter what phone you use, whether it be an Android-based phone or an iPhone or whatever it is, all of these phones have a very common application called contacts. Okay. That was the purpose why phones were built. But again, in today's world, we use phones for all other purposes, but for making calls. So, but again, so you still have this application called contacts, and the main purpose of it is just to save these contact numbers. So again, in your life, you meet a lot of people and you contact them through their contact numbers, right? And whenever you take down a contact number, you assign a name to it. Because we humans are terrible at remembering long sequences of numbers. Okay, so we practically cannot remember the contact number of every person. And we have a contacts app. Okay. And what does the contacts app do? It links a contact number with a contact name that we assign. Okay. That's the main purpose of it. Okay. So in your phone, you could save my number as well. So my number 98499847778 could have been saved in your phone with any name of your remembrance. Okay. So in order for you to remember me of so and so person, you will assign a name to it. So cyber security trainer, blah blah blah. Okay. And now whenever you want to make a call to my number, the relevant factors there are your phone number and my phone number. It is not relevant what you save the name as. You could have saved it as Shoaib or cybersecurity trainer, prolog info trainer, or whatnot. Okay. So that name is only for you to remember who this person is. Okay. But the connection is being made on your 10-digit number and my 10-digit number. Right. Similarly, when you go to your browser, and in your browser, when you search for a domain name like google.com, your browser doesn't understand this language. What it needs to connect to google.com is the public IP of the server of. So somewhere on the internet, there's a huge web server. And on that web server, this website google.com is hosted. Okay. And that web server has a public IP, some random 1, 2, 3, 4 public IP. So what your browser actually needs is that public IP to connect to it. Okay. So from your system's public IP, it initiates a connection to that public IP. But where does it get that public IP from? Okay. So in between with your ISP, there's a DNS server. And in that DNS server, you have records saying google.com is linked on so and so IP, bing.com so and so IP, youtube.com so and so IP, shrow.com so and so IP. So basically, these are called DNS records. And a DNS record contains a linking between the domain name and the IP address of that web server. Okay. So a DNS server is like the internet's phone. translating human readable domain names into IP addresses. Okay. Because as mentioned, all the connections on the internet are made with public IPs itself. So once it gets to know what the public IP for google.com is, with that public IP, it reaches the exact internet web server. Okay. If I show you an example for this, I can go to my command prompt again. And in my command prompt, I can run a command ping, ping, www.google.com. Okay. And when I do that, you can see I'm getting a public IP here, 142.250.205.228. If I copy that IP and if I paste it in my browser, carefully observe what happens when I hit enter. It accesses Google for me. Okay. So this was the actual IP for Google, but we don't have to remember this number, this huge random number, because there's a DNS server in between translating this IP to the domain google.com. Okay. Is that clear, everyone? What the DNS server is and what it does? Any questions? Jeevan, Sandeep, Sumit, Vaibhav, Sanya, everyone. Is that clear? Again, very important protocols, guys.
No.
DHCP protocol, DNS protocol. We'll be working on these in the upcoming sessions as well. DNS server again. No problem. Again, as mentioned, guys. So 1 second, guys. I think my laptop's battery is a bit low. Let me quickly connect the charger. Just give me 1 minute. Right. So as mentioned, guys, whenever you want to connect to any website on the internet, you cannot directly connect it from the domain name. So google.com is the domain name. So when you enter google.com in the browser like this, www.google.com, your browser does not understand this language. In order to connect to google.com, it actually needs the IP address of google.com. And that IP address is stored in something called a DNS server. So these DNS servers are usually maintained by your ISP, Internet Service Provider. Okay. So when you search for google.com, that request goes to the ISP. From there, it reaches to a DNS server. And from the DNS server, it queries and it tries to figure out what is the IP for google.com. So from the table, it gets to know, okay, google.com is located on so and so IP. And with that IP now, it reaches the correct server with that IP. Okay. So the DNS server is like the internet's phone book. It is having a record of every domain with its linking IP address. So it is translating human readable domain names into IP addresses and vice versa. And with that DNS server only, you're able to connect to any website on the internet. If there were no DNS servers, your browser would never have understood these alphabets. And you would have to remember the IP address of each and every web page you want to visit. Since we don't want to remember those numbers, we are assigning a name to that number, a domain name. And those linking between domain names and IP addresses is done in a DNS server. Okay. So it's the internet's phone book translating human readable domain names into IP addresses. Okay. Is that clear, everyone? Vaibhav, Sumit, Sandeep, Jeevan. Right. Moving on to the last concept for today is special IPs. So in your entire range of IP addresses, guys, from 0000 to 255, 255, 255, 255. Until now, we have only discussed two categories of IPs, public and private. But other than that, there are also two other special IPs. Now, these IPs are not public IPs. I mean, neither public IPs nor private IPs as well. These IPs are only used for troubleshooting. You cannot use them for connectivity. Okay. So the first special IP is loopback IP. Now, these loopback IPs range from the number 127.0.0.0 to 127.255.255.255. Okay. And the entire range of this number is neither a public IP nor a private IP. The only purpose of both these IPs is troubleshooting. Okay. Loopback IPs are used to check if your NIC card is working properly or not. Okay. But what do I mean by an NIC card? So if you go to your browser, and in the browser, if I search here, NIC card, it stands for Network Interface Controller Card. Okay. And this is what it looks like by default. If I open up any of these images here. Yeah. This is what an NIC card looks like, guys. So if your laptop has an Ethernet port, right beside that Ethernet port, you have this chip connected. And this chip is the main networking component chip. All the network interface physical components are present on this one single chip itself. The Ethernet port, the Wi-Fi chip, the Bluetooth chip, all the networking physical components are present on this one chip. And if this chip malfunctions, your system will not be able to get any sort of an IP. It will not be able to get a private IP. It will not be able to get a public IP. It cannot communicate with any other device. Okay. And just to verify if this chip is working properly or not, you have the loopback IP. How do you check? Open up the command prompt and run a simple command ping and the loopback IP. And please note, you can give any IP with the first octet 127. So you can give 127.0.0.1 or 255.255.254. Anything would work the same way. It should give you a reply back. So 4 packets were sent, 4 packets were received, 0 packet loss, which means 4 packets were sent to your NIC card and your NIC card responded back with 4 packets and there was 0 packet loss, which means everything is working perfectly. Okay. And the reason why it's called loopback is because you're trying to ping to your own system. There's a loop forming there. You're telling yourself hi, and you're getting a response hello. Okay. Hence the name loopback. Okay. And then you have the next IP, APIPA, which stands for Automatic Private IP Assigned Addresses. Okay. So these APIPA IPs range from the number 169.254.0.0 to 169.254.255.255. And these are a special case IP, which is assigned to your system when your system cannot retrieve an IP from other sources. So as mentioned, there are two sources from where you get the IP. You can either get it dynamically from a DHCP server, or you get it manually from a network admin, or you assign it yourself. Okay. In the scenario where your system cannot get an IP from either of the sources, then the operating system itself, the Windows OS or the Linux OS or whatever OS you're using, that OS itself assigns an APIPA IP, automatic private IP assigned address. So whenever you see an APIPA IP in the command prompt, it basically means something is wrong with the network and your system is unable to retrieve an IP from both the sources, manual and automatic methods. Okay. So these are the two available special IPs in the entire range of IPv4 addresses, guys. Nothing further. There's one more concept called CIDR, but don't worry, I'll talk about this in the Linux commands class. Not important right now. Okay. This is just another representation of the subnet mask. Okay, we'll talk about this later on. But yeah, this concludes the entire networking portion. Okay. A quick recap on all what all we have learned in the last 3 classes, guys. First, we talked about what networking is, what networks are, and what hosts are. If I go back to the first slide here. Yeah. So we talked about networking, what are networks and what are hosts. Then we talked about specifically IPv4 addresses and the properties of IPv4 addresses. Then we talked about how do you convert any binary number to a human readable decimal number to get the range of IPs. What's the first IP? What's the last IP? From the range, we figured out there are 4.3 billion IPs, and we talked about the sequence of IPs. Then we talked about the different classifications in them. Classes, class A, B, C, D, and E, and the difference between public and private IPs. And again, we also discussed the range of each class and the private IPs in each class. We did some exercise in the last class to figure out which IP belongs to which class. And then I explained the relevance of each of these classes until yesterday. Today, we learned about subnet mask. We learned about how to assign a private IP to your system, both manually and automatically from a DHCP server. Then we talked about a DNS server, and then we talked about special IPs. That's the entire quick recap of what we have learned in the last 3 sessions, guys. This concludes the networking part. And in tomorrow's session, we get into the next part, which is practical hands-on lab setup environment. Okay. So how do you install this application called VMware? And within that VMware application, how do you install Kali Linux is what we talk about in the session tomorrow. Okay. So Kali Linux is basically an operating system, guys, built on the Linux kernel. And this is one of the most important operating systems in cybersecurity because this comes pre-installed with all the cybersecurity tools. It was built for the purpose of penetration testing, one of the best operating system, completely open source and free to download. And it has a lot of tools available in it, which are very important for us, okay, to perform penetration testing and cybersecurity, other operations as well. Okay. So in tomorrow's class, I'm going to show you how do you install this operating system called Kali in your base machine. Okay. So yeah, that's that. Nothing further. Any questions, any doubts in today's class? A simple and a short session to conclude networking fundamentals. Any questions, Sanya, Jeevan, Sandeep, Sumit, Vaibhav? Perfect. So yeah, that's that. Nothing further for the session today, guys. Please do. IP and domain names are unique. Yes, Jeevan. Domain names will always be unique along with IP addresses as well. Okay. So, but again, sometimes there's something called dynamic IPs. So what IP you might get for a website today, tomorrow you might not get the same IP address. Okay, tomorrow you might get a different IP. So these IPs are provided by the DNRs, domain name registrars. Okay. So again, but the domain name will always be unique. So once a domain name is registered, one the person can register the same domain name again. Okay. Domain names are always unique. IP might keep changing. It is definitely unique. So once you get an IP, no other person in the entire world will get the same IP. Okay. But it's dynamic. It keeps changing from day to day. Okay. So that's what the relation is. Is that clear, Jeevan? Hello. Right. Assuming no questions, we can exit the session here, guys. And tomorrow we connect back to learn the first practical hands-on class. Okay. So we'll be connecting tomorrow to perform lab setup installation along with the Kali Linux installation as well. Okay. Please do join the session tomorrow. Quite an interesting session. Okay. Bye-bye. Good day. See you tomorrow at the same time. Bye, guys. Good night.
Thank you.
Thank you, guys.